Okay, let me start my presentation on my final year project titled Wireless Big Data Transceiver for IEEE 8.11 Networks. My name is Wang Linghui. First of all, let me introduce the motivation part of my FYP. As we can see from the graph, with the data rate increasing, the MAC layer efficiency is decreasing accordingly. How come? Because there are large overheads are added to each frame transmissions. So, as the frame transmission can only transmit it once with a large overhead, therefore with data rate decreasing, the efficiency will become lower and lower. So how can we cope with it? So our solution is that we will enlarge our data packets to deal with these problems. Hence, in our work, we firstly implement a single-in and single-out OFDM systems based on LabVIEW platform. And in this system, we use USRP, which is a hardware transceiver, can monitor actual single-point communication waveforms, which connected to LabVIEW, meaning that if we change the parameter in LabVIEW, the coding USRP will also change according to the LabVIEW. So we can construct the whole system based on the transmitter and receiver and the software, so we connect it perfectly between the software and hardware. Yeah, and it's very helpful for us to adjust our single-in, single-out FDM. And based on these systems, we can modify the system mechanism which is related to the information transmission, the recovery part, and then to accomplish enlarging the data packet size, finally to improve the throughput performance. So, what's the single-in, single-out OFDM system? The single-in, single-out means that there is one radio and one antenna. In this case, we discard the multiple antenna case. As for the OFDM, the basic principle of the OFDM is to split a high-rate data stream into a number of low-rate streams that are transmitted simultaneously over a number of subcarriers. It eliminates the problems of inter-symbol interference, low spectrum efficiency, and frequency selective fading. The difference from the normal transmissions, we could see that the channel is divided into n non-overlapping subchannels to avoid intercarrier interference. Plus, as the frequency of each subcarrier is orthogonal to each other, so for bandwidth efficiency, it would be very high, higher than other transmission systems. Besides, in order to diminish the effect of intersymbol and intercarrier interference, we could copy the tail of the signal and glue it to the front. In this case, we could just easily diminish the effect of the ISI and ICI. As these two are mainly the basic algorithms of OFDM systems, as our project focuses mainly on how to enlarge our payload size. So we mainly focus on the information transmission and the recovery part, which related these algorithms. First, I will introduce the short training sequence, which we could see from the diagram that is appended in front of the following transmitting OFDM symbols. It is used to estimate the following OFDM symbols by these two algorithms. These algorithms use the priority and created in the OFDM symbol to accomplish the frequency offset correction and frame synchronization. And this algorithm estimates the channel conditions by the short training sequences. As our final goal is to enlarge the data packet, but the data packet cannot directly enlarge. It should be accompanied with the different short training sequence inserting algorithms. For example, we can in this case we insert the short training sequence in front of the symbols. If the symbols would be larger, and maybe we need an extra training sequence behind these symbols or in between the symbols to achieve a better estimation or synchronization of the channel. This will be discussed in our future work. So, as for the method and tools, we utilize a LabVIEW platform, which is a visual programming language used for us to construct the basic systems, which can be shown here. This is the block diagram based on LabVIEW systems, and this is OFDM transmitter part of the transmitter. This is part of the receiver. And till now, we already have constructed the whole single-in, single-out OFDM system in LabVIEW systems. And based on these systems, we already can transmit small data packets with good performance. So next semester, we'll focus on how to transmit large data packets with good performance. So we focus on to implement this, can send large packets. We may construct several methods of inserting the short sequence of pilots into OFDM symbols. And of course, we'll change the respective methods of channel estimation and synchronization to deal with the large data packets. And these are our future work next semester works. And that's all over about my FYP for the first semester. Briefly, I just implement a single-in, single OFDM, based on which I will modify these algorithms to achieve a better system that can send large package with a good performance. Thank you.